Hey everyone, and welcome back to our problem solving series for the Instagram problem that I posted on April 2nd. So what we have is we have three lines: y is equal to 5, y is equal to negative 3x plus 5, and y is equal to 1/3 x minus 9. These three graphs are going to intersect at specific points A, B, and C to form a triangle. And what we need to do is we need to find the area and the perimeter. So let's go ahead and examine the red line, which is y is equal to 5. If you notice, that crosses the y-axis at 5, and that's going to be one of the coordinates, 0, 5. Another way we can look at it is the blue equation also crosses at that specific point, and that happens to be the y-intercept for y is equal to negative 3x plus 5. Now let's go ahead and find problem or point C in this case. That's the point of intersection for the equation y is equal to 5 and y is equal to 1/3 x minus 9. So we have the system of equations here. Let's solve it by substitution. Let's go ahead and make 5 equal to 1/3 x minus 9. What we can do is add the 9 to the other side, and we're going to get 14 is equal to 1/3 x. We're going to multiply 3 to both sides, and that's going to give us 42 is equal to x. We already know that x is equal to 42, and we're going to know that y is equal to 5. We can solve that by plugging it back into the equation for the green function, or we can just observe that it's the same thing as y is equal to 5. So now we have our point C. Let's go ahead and find the point B. Point B is a point of intersection of the blue line and the green line. So how are we going to find that? We are going to find the solution to the system for y is equal to negative 3x plus 5 and y is equal to 1/3 x minus 9. And again, let's solve this using substitution. Let's go ahead and set negative 3x plus 5 equals 1/3 x minus 9. There's a couple ways to do this, and a lot of people don't really like to mess with fractions. So what we can do is we can multiply 3 to both sides. And when we multiply 3 to both sides, we need to make sure that we distribute the 3 to every single value. Now on the left side, we're going to give negative 9x plus 15 is equal to x minus 27. Notice that the 1/3 goes away. And that's essentially what we wanted to do. We want to multiply by 3 so that we get 1/3 times 3 is equal to 1. And I could even write 1 here just in case people are getting confused. Okay, so let's go ahead and add the 27 to the other side. Let's add the 27 to the other side. Okay, so we get negative 9x plus 42 is equal to 1x. Let's go ahead and add the 9 to the other side. And that gives us 42 is equal to 10x. Okay? Let's divide the 10 to both sides, and we get 42 over 10 is equal to x. Now, for the purpose of this problem, I'm just going to simplify the 42 over 10 and turn it into a decimal and just make it 4.2. So now we know the x value is 4.2. How do we find the y value? We can actually plug that into any one of the equations here. We can plug it into the first one or the second. For the sake of not messing with the fraction, I'm just going to plug it into the first one and get y is equal to negative 3 times 4.2 plus 5. Okay? You can use a calculator for this if you like, and get negative 3 times 4.2 is equal to negative 12.6 plus 5, and that gives us y is equal to negative 7.6. Now that's going to be the y value for the coordinate for B. So we know that B is 4.2 comma negative 7.6. Okay, that's step 1 essentially. Now step 2, we need to find the distances between each coordinate so that we can find the perimeter and then we can find the area. All right, so let's go ahead and find the distance or the value of the line segment AC. If you notice, AC is just a straight line. It starts from 0, 0 or 0, 5 to 42, 5. Now we can use a distance formula here, or we can just observe because they have the same y value. The distance is really just the difference between 0 and 42, so that's going to be 42. So we know that AC is 42. All right, let's go ahead and find the value of the segment AB. Now the coordinate for A was 0, 5. The coordinate for B was 4.2 comma negative 7.6. Okay, so now we're gonna have to use a distance formula. So what is the distance formula? Keep in mind that it's x of 2 minus x of 1 squared plus y of 2 minus y of 1 squared. All right, let's go ahead and plug those in. So now we're gonna get 5 minus 4.2 squared. Oh, I'm sorry, it's not 5. Our x2, I made 0, so 0 minus 4.2 squared plus my y2 is 5 minus negative 7.6. We have to be very careful by putting in that negative there, because if we don't, we're going to get mixed up and we're actually going to get an incorrect value. All right, so I have negative 4.2 squared plus 5 minus negative 7.6 is essentially 5 plus 7.6. So which is going to be 12.6 squared. So I'm going to go ahead and plug that in the calculator. Okay. By the way, as I'm writing this, keep in mind that it's very important to know the distance formula, right? Not only, you know, memorize it, but at the same time, just keep in mind that it's something that is going to be so useful. A lot of students like to, you know, just think that you're going to use it once and you're going to forget about it. I think distance formula is one of the most useful equations that we can have out there. Okay, so we found the value of AB, which is going to be 13.3. Let's go ahead and find the value of BC. All right, so the coordinate for B, we already knew was 4.2 comma negative 7.6. And the coordinate for C was 42 comma 5. All right, now using the distance formula, I'm gonna go ahead and write my x2 is gonna be 4.2. So 4.2 minus 42 squared plus negative 7.6 minus 5 squared. All right, let's go ahead and use our calculator. For this, we're gonna get negative 37.8 squared plus negative 7.6 minus 5, which is negative 12.6 squared. You know what's so funny? We should have known that because we used that equation for the previous line segment. But anyway, so let's go ahead and find the distance. I'm gonna plug that into my calculator. And I'm gonna get 39.9. So that's the value of BC. Okay, so if you look at the diagram that I have for you guys, we can see that we now have the line segments for every single value. We have BC is equal to 39.9. We have AB was equal to, I believe it was 13.3, and then we have AC is going to be 42. All right. So now we can start with the perimeter. How do you find the perimeter? Again, one of the useful equations that we should know. The perimeter is the values of the lengths of the sum of all the lengths of the shape. So we have a triangle where we have 13.3 plus 42 plus 39.9. Okay, plug that into our calculator. And then we get a perimeter of 95.2. And let's go ahead and put units there. All right, so that's the perimeter. How do we find the area? Well, we have a triangle. If you notice, the blue line, which is y is equal to negative 3x plus 5, and the green line, which is y is equal to 1/3 x minus 9, are perpendicular. Why? Because their slopes are opposite reciprocals. We have a negative 3, and then we have a 1/3. So that means that that triangle ABC has a right angle at B. So we can easily use the equation 1/2 base times height. Now 1/2 times the base, let's make the base BC, that's 39.9, and the height, which is AB, let's make it 13.3. 0.5 times 39.9 Awesome. So if you notice, there's a couple things that we had to know here. We had to know systems of equations. We had to know the distance formula. And we had to know how to find perimeter and area of a triangle. All right. Anyway, I hope you enjoyed this explanation. I'll see you guys soon.